and welcome to the video. In this video, we are going to discuss the idea of best by proportion questions. We're going to look at a few different ways of approaching best by questions. Essentially, in each question, you need to make something the same. So then you can compare to see which of the items is best value. We're going to start with the two questions on the screen, quite easy questions as an introduction to the topic. And then we're going to move on and look at an approach we can apply to every type of best by question. So if I have a little look at question 1 here, we have a large bottle of Pepsi and a smaller bottle of Pepsi. The large bottle costs £1.20 and the small bottle costs 45 pence. If we want to determine which is the best value, we need to manipulate something, change something, so that we can do a nice comparison. So the easiest thing to change here is if I look at the small bottle, it currently has 200 milliliters. If I was to multiply that by 3 along with the price, then I would have a comparison because they would both have 600 milliliters. And that's exactly what I've done when I've went to answer the question. So you can see from the top, I've wrote out the original question. So I did start with 200 milliliters being 45 pence, but I've multiplied that by 3. So I've now changed it into 600 milliliters, and the 45 pence times 3 gives me £1.35, or 135 pence if I wanted to speak in pence. So now I can do a direct comparison. You can see that the large bottle, for 600 milliliters, it costs you £1.20. And for the smaller bottle, if we were to buy the same amount of volume, we'd be paying more. We'd be paying £1.35, so 15 pence more. So therefore, I can make a statement that the larger bottle is better value. This works out cheaper. So this is my best buy. If I look at the second question, we're going to do something quite similar. If I look at the weight of each chocolate bar, I've got 140 grams, and then I've got 275 grams. In order to multiply them up to get a common multiple, we'd end up dealing with a very large number. So what we could do this time is look at the prices. So the large chocolate bar costs 60 pence, and the small chocolate bar costs 30 pence. So at the minute, I can't do a direct comparison because nothing is equal. But if I was to multiply the information I have from the small bar by 2, then I would be dealing with 60 pence for both bars. So that's exactly how I've approached this question. So you can see here that I took my information, 140 grams of chocolate cost me 30 pence. So I multiplied those values by 2. So now 280 grams cost me 60 pence. And because I have 60 for the small bar and 60 for the large bar now, I can do a direct comparison. So you can see here I get more chocolate for my 60 pence than I do here. So in this question, the smaller chocolate bar is better value. The smaller chocolate bar is my best buy. So that's all well and good for questions like we just saw on the previous slide, where it's quite intuitive to make either the price or the quantity equal. And that often will be an approach that you can apply to best buy questions. However, we also need to look at the unitary method, which is a method that allows us to work out more complex questions. It's a consistent method that will work for any best buy question. So it's the approach I usually use when solving typical exam questions on this topic. What we're going to do is we're going to apply this equation. Whatever the items in the question are, we're going to take the price of the item and we're going to divide it by the quantity to find the price of 1 unit. So for example, it might be price divided by milliliters to find the price of 1 milliliter. It might be price divided by grams to find the price of 1 gram. Or it might be how many chocolates are contained in a box. So in which case it would be price divided by the quantity of chocolates to find the price of 1 chocolate. So we're trying to find the price of 1 unit of both things or more things in the question, so then we can do a direct comparison. So we're still making things the same, but this time we're making them the same to the equivalent of 1 unit. As you'll see from the remaining questions in this video, we start to deal with some quite complex prices and quantity divisions. So you are allowed to use a calculator when you're applying this method. So in any of the questions for the remainder of the video, calculators are allowed to help you with those divisions. Let's have a look at how that would work with a few example questions. Okay, so we've got a question at the top of the screen here. Which jar gives the better value for money? You must show your working out. We've got a smaller jar of coffee which costs £3 and contains 200 grams. We've got the larger jar of coffee, costs £4.80 and it contains 300 grams. So we could approach this question by multiplying this by 3 and multiplying this information by 2, so they both have 600 grams, but I'm going to approach it using the unitary method. So this is what my working out would look like. Notice for both questions, I've changed the price into pence, because the answer I'm going to get is going to be pence per gram. So what I've done here is I've done my price, 300 pence, divided by my quantity, 200 grams. So this is telling me that my price per 1 gram is 1.5 pence. 1.5 pence is the price of 1 gram for the smaller jar. If I do the same with the larger jar, I take its price, 480 pence, divide by its quantity, 300 grams. So this time I find that the price per 1 gram is 1.6 pence. So you can see the price for the larger jar is slightly more expensive, 1.6 pence as opposed to 1.5 pence. So then I can make a statement. The smaller jar of coffee is the better value. The smaller jar is my best buy. Here's another question, this time a little bit more complex. We could go ahead and multiply up the value. So we could multiply this information by 5 and this information by 2. So then things would be the same and we could do a comparison. That's one way of approaching the question. However, I'm going to approach the question using the unitary method. So I'm going to work out the price of 1 wash from the standard size and the price of 1 wash from the large size, and then compare the price for 1 unit, 1 wash. Okay, so here's my working out. Looks like this. So again, for each question, I've changed my cost into pence because I know that the answer I'm going to be dealing with is going to be in pence. 248 pence divided by 10 tells me that the price per wash is 24.8 pence. So price divided by quantity of 10. So the price for 1 wash is 24.8 pence with the standard size. And for the larger size, price divided by quantity of 25 tells me that the price per wash is 23.96 pence. So you can see that the price for one wash is slightly cheaper when we're looking at the large size box. So this is our better value. This is our best buy. So then I can go ahead and make a statement. The large size of washing powder is better value. Because if we look here, when we're comparing 1 unit to 1 unit, 1 wash to 1 wash, this price is cheaper, so therefore it is our best buy. Let's have a look at another example. Again, you have the ability to pause the video at this point. So if you want to have a go at this question before I explain it, then pause the video now and work ahead. Okay, so which of the two packs gives better value for money? You must show all your working out. So we've got a packet of paper here, which contains 150 sheets, and a packet of paper here, which contains 500 sheets. We're going to use the unitary method to work out which is the best value. So my working out is going to look like this. I'm trying to work out the cost for one sheet of paper, the price for one sheet of paper. So in the first question, I take my cost of 95 pence and divide it by quantity of 150. So that's telling me that one sheet of paper costs 0.633 pence. In my second calculation for the regular box of paper, I took my cost, 320 pence, divided it by a quantity of 500. So the price I'm paying for one sheet of paper is 0.64 pence. So there's not much difference between the price of one unit, between the price of one piece of paper. However, there is a difference. This is very slightly cheaper. So this is my best value. This is my best buy. So I can go ahead and make a statement. The standard pack of paper is better value. That is my best buy because it is slightly cheaper. When we come to do these comparisons, the amount of decimals that you need to keep your answers to will be dictated by the question. So for example, I just wanted to extend this to 3 decimals, just so when I did my comparison, it was a bit easier to see. So in some of the previous examples, 2 decimal places may be enough, but sometimes you will need to extend to 3 or 4 decimal places if the prices are very, very close together. So 3 or 4 decimal places will give you that confidence to make your statement of which is the best buy. At this point in the video, I'm also going to comment that we could have done the divisions the other way around. We could have been working out quantity divided by price for each of the questions we've had a go at. Quantity divided by price. So that would then tell us the quantity of paper you get per 1 pence. So we could have done the division the other way around to find out the quantity of paper per 1 pence. And then we would be able to compare, and we would be selecting the biggest value because we want the most amount of paper for 1 pence. However, I think when you start using both methods and sometimes applying one and sometimes applying the other, that's when students start to get confused. So for me, for consistency, we always use the unitary method, which I've explained in this video. Price divided by quantity. And then we look for the smallest value per unit. So now it's your turn to have a go at a few questions. I've put 6 questions on the screen. I'd like you to have a go at answering each question and making a statement which is the best buy, which is the best value. For each question, you need to show your full working out, so you must show your working out, and you must end the question with a statement, which is the best value. Have a look at each question in detail and decide whether you can use the method from the very first slide, where we just multiply up a value to do a comparison, or do you have to apply the unitary method by dividing to find the price of one unit? Okay, could you pause the video at this point and could you have a go at all 6 questions? Okay, welcome back. I'm just about to display my answers on the screen and I'll show you my full working out, and then I'll talk through a few of my answers. So here are my solutions. You can see in the first question, when we're dealing with the can of 7-Up, we can use the easier method of multiplying to find our equivalent values. So if I was to take the small can and multiply its information by 3, I would then be left with 600 milliliters and 600 milliliters. So I can do a comparison of the price, and you can see that this is the smaller price, so the larger can is better value. Question 2 is very similar when we're dealing with the box of Maltesers, the box of chocolates. This time, if we multiply the price by 3, so we get an equivalent price of £1.80, then we can compare the weight, we can compare the grams, the amount of chocolate, and you can see that the larger box, for the same price, contains more chocolate, has a greater weight. So again, we can state that the larger box is better value. For the remaining 4 questions, I've applied the unitary method. So I've always applied price divided by quantity to get the value of 1 unit. So for example, in question 3, it was price per wash and price per wash. And you can see that this was the lower value, so the smaller bottle was my best buy. And I've worked through the remaining questions showing my working out. Just one thing to note on question 6 is when we go ahead and do price divided by quantity, if we were to round it to 2 decimal places, we'd end up with 0.21 pence per milliliter, but we'd end up with that answer for both values, for the smaller bottle and the larger bottle. So in question 6 in particular, we need to consider looking at further digits after the decimal point. We need to consider looking at more decimal places. And when we do extend it slightly, you can see that the smaller bottle is very slightly cheaper. But mathematically, it is cheaper. It is our best buy. So again, I can make a statement. Very well done if you were able to work through all 6 questions and apply different methods to find your best buy. That shows a very good understanding of this topic. Well done.